Okay, so you have a handout in front of you. You're not going to need it for just a couple of minutes. I'm going to give you some sort of general thoughts to begin with. And then today you're going to know what current electricity is, understand how static and current electricity are related, and the number one thing, be able to solve current electricity word problems using the formula I equals Q over T. You're going to be solving problems today, mathematical little problems. So, I ask you, how are static and current electricity the same and different, Charlie? How are static electricity and current electricity the same and or different?
They're both electricity.
They're types of electricity. They involve electrons. Right, what about difference? How are they different? Their names are different. That's true. That would imply that there's something else different. Where do we find current electricity?
In the sentence?
Oh, like in everyday life. Travis, where do we find current electricity? In his hair? No, that would be static electricity.
Drawing machine.
Mason, what about you? Current electricity? No? In the outlet, right there, where you plug in your TV. That's current electricity. So how are they the same different? Current. Okay, ready? That's the main difference right there. If I ask you this on the test, that's what I would expect for you. Okay, guys? Electrons not moving, electrons moving. Which one is which, Charlie? Don't know? Current electricity.
Electrons moving.
Electrons moving. Exactly. Okay. Remember when we did the pie plate thing, right? We charged the styrofoam by rubbing it, then the charge was transferred to the metal plate. It became negative. Electrons moved to our finger when we touched it. But it only happened once. Chris, I need you to listen. I'm explaining things. Brandon, I need you to stop slurping loudly, please. What if there was some way to keep the styrofoam, keep rubbing the styrofoam, keeping it constantly charged? And you guys did that, and we would constantly get that spark. Charlie, listen to me. Charlie, listen to me.
Ooh, a finger. Oh, look at the
Okay. So, if we were to continue rubbing the styrofoam plate, we'd be continuing to add charge to it, and we got that light to light up, and that, my friends, is the basis behind current electricity. Okay? We just didn't do a very good job of it, kind of thing. Okay? And when we did the Van der Graaf generator, did we have a current happening? Close, we're getting there, right? We had to have that thing winding around, standing, and the charge builds up, and every time you touch, you get a shock, and if you touch it again, you get a shock, right? We're getting there. If you stick your finger in the socket, well, you're going to get a shock right away, right? It's a better example of current electricity.
Why do they call it a Van der Graaf generator?
I guess a guy named Van der Graaf made it. I don't know. It's a good question. I don't know. Okay. So here's where the handout comes into play. Right? So you should now have that handout right in front of you. You should have a pen or a pencil out. You should have your device face down on your desk. I do.
I'm for it.
Pull it out, put it on the desk.
I'm for it. I can't. I can only afford it slow.
I can't. If I don't need daddy.
Yeah.
Okay. Put a box around that formula, please. I equals Q over T. Put a box around that, Brandon, right now. Well, you don't even have it. You got to write it down, don't you? You need to write that down. So current is defined as the amount of charge per unit of time. How much charge per unit of time? And the formula is I equals Q over T. I stands for current. I stands for current, and Q stands for charge, and take a wild guess what T stands for.
Time.
Time. I is current, Q is charge, T is time. How come we don't use C for charge?
Yeah.
C is current.
Or how come we don't use C for current? Well, we couldn't use, like, we can't use it for both. We couldn't have C equals C over T, right?
Doesn't matter. You
And I'll give you an idea here. C is actually a special letter that they use for the speed of light. And because the speed of light is so fundamental to the universe, that's the only, it's kind of like retiring Gretzky's number. C has been retired, it's the speed of light. Okay? So they use the letter I. I have no idea why. They use the letter Q for charge. Again, I have no idea. The other versions of this formula are Q equals IT. And Charlie, you should be writing these down. Excellent. Or T equals Q over I. If you're asked to find current, you're going to use this one. If you're asked to find charge, you use this one. If you're asked to find time, you use this one. Do you have this at the bottom here, this note?
Yeah.
Excellent. Note that time is always measured in seconds, Jonathan. And everyone knows there's 60 seconds in a minute, and 60 times 60, or 3,600 seconds in an hour.
Holy mail.
Okay, do you have that there? No, you have to fill that in, right?
3,600 seconds.
3,600 seconds in an hour,
It
yes.
doesn't even sound like much if you put it like that.
I guess if you counted for a whole hour at 1 second per number, you'd get to 3,600.
But chances are you'd screw up kind of.
Probably you'd get tired of it because it'd be, yeah.
And then you could start going faster and slower.
Yeah, you're right. Okay, so before we can get into the real stuff, I have to talk about sample time conversion forms with you. How many seconds in 4 minutes?
24.
4 minutes times 60? 240. I think most people can do that, right? Maybe even when I calculate it.
Oh, I guess there's stuff I don't mean that.
4 times 60 is 240. Right?
How greedy though.
How many seconds in 0.75 hours? Travis,
2,700.
how'd you get that?
Because I did 36 divided by 4 equals 9, and 9 times 3.
Okay, you could do that. He went 3,600 divided by 4 times by 3, because that's 3/4, right? What if I told you, Travis, you could go 3,600 times 0.75? Would that give you the same number?
Yeah.
Sure would, right? What was that number, 2,750?
2,700.
2,700.
That's the size of the
Okay? So if you're struggling with time conversions, you can look back at those for help, Jonathan, right? All right.
I agree.
This is important.
They don't drive.
Okay. Listen carefully, you guys. When you're solving these problems, Brandon, when you're solving these problems, these are the steps that I'm going to require. I'm a little bit of an ogre, a little bit of a...
It's all ogre now.
I'm a little bit jerkish about it, okay? And there's a reason for that. It will help you. As you progress to grade 10, grade 11, grade 12 physics, I'll reduce the expectations, but you'll be better at it. So for now, I do this to help you. I want you to state the variables given, the numbers, and the unknown variable. That's job 1. Okay? And I'm going to show you what I mean by this right away here, Brandon. Job 2, write the formula to use. I still make my grade 12 students do that. It's important, Mason. It tells me that you know how to do the problem. Substitute the given numbers in, solve using math, check that the units are written. I make my grade 12 students do that as well. Units are important. Travis, how's like 100,000? Exactly. Does he like $100,000, but he sure wouldn't like 100,000 smacks in the face. Units are important. Units are important. Check that all the equations, Brandon, have variable symbols or numbers before and after the equal sign. Some of you are going to need some work on this. Okay? Neatness is important. It really is. And some of you are going to battle on this. Okay, here is a sample question. Flip your page if you haven't done so already. Flip your page. Okay, let me walk you through the steps. 240 C of electric charge passes a certain point. Guys, I need you to watch, because you're not going to know how to do this later. 240 C's of electric charge past a certain point in a circuit in 5 minutes. What is the current through that point? There's 3 letters you need to write down on the left-hand side. They are I, Q, and T. Write them in right now. I, Q, and T. Those are the 3 letters we're dealing with. Now we have to write in what we know, Jaden. 240 C's of electric charge. 240, is that the I, the Q, or the T? It's what, Jonathan? It's Q. How do you know? Because it's 240 coulombs of charge. Which one is charge? Q. So 240 goes in with Q. Braden, why is the Q 240? No? Q is the charge. Is that what you're going to say, Mason? Good. Okay. What about this 5 minutes? Which one is it? T. But, is it in seconds? No, it's not. So you got to show 5 minutes times 60.
30,000.
Um,
Or not,
300, yeah. 300 seconds, right? One too many zeros. 300 seconds, which means I'm solving for I. If you want to put a question mark, you can, you don't need to. We are solving for I. Which formula has the I out front? The first one? So, I equals Q over T. You gotta write the formula. I equals Q over T. I'm a bit of a stickler for lining things up. Now I want I equals, line up your equal signs. That's what I expect. What's my Q? 240 over 300. Write your answer. Take your calculator, your phone, or whatever you got that has a calculator on it, and divide.
I ain't down with this.
0.8, I think, right? Now,
What is I?
I stands for the current. I stands for the current. Now, it's 0.8 what? Because units are important. What do we measure current in? I don't think I told you yet, have I? You measure current in amps. Named after Ampere, French dude, scientist dude. Ampere, amps. The symbol for amps is just the letter A. If you look on the back of any electrical device, like the fan back there, or that weird looking oven thing, or my pencil sharpener, there will be like a rating for amps. Okay. Okay, good. Let's go through the steps. Have I done everything, Jaden? Go through the steps. What's step 1? State the variables given in the unknown variable. Did I do that? Over here. Brandon, watch. Write the formula to use. Did I do that? I did. Did I substitute the given numbers into the formula? That's what this is right here, substitution. Did I solve? Yes. Did I check that units are written? Yes. Do I have something before every equal sign and are the equal signs lined up? Yes. That is a perfect solution. Do I have beautiful typewritten, handwritten text? No. It's kind of messy, it's kind of ugly. But I've done everything. I can read it. You try this one right now. I've given you the tools. You try this one. Follow the steps. Give it a try. Here's a little help. A stereo in a home is on, and it uses, the word they use in these problems is draws 12A for 30 minutes. How much charge is this? Write the letters I, Q, and T. T is the easy one to find all the time, right? You want to do that first? T is going to be 30 minutes times 60 is 1,800, right? Did I do that right? Okay. Which one is which here? How much charge in coulombs is this? So we're solving for charge. Charge is which letter, Grady? Q. So that's my question mark. 12A, 12 amps is my current. Okay, there's your help.
What? I got it.
Good. Okay, I'm going to wait a few seconds and then I'm going to show the answer. Yeah, 5 minutes. Okay, which formula do we solve for Q with?
I times T.
I times T, that's the times, right you are. So you're going to write Brandon Q equals I times T. Then you're going to substitute Charlie. Charlie, what's my I?
Here.
12. Times my time, which is 1800, and you are going to need a calculator for that. Give me the number. I don't have a calculator here. 21,600. That sounds familiar. 21,600 what? No. Q is measured in coulombs. I haven't told you that either. Coulombs, named after Charles Coulomb, another French dude, is the unit for charge. 21,600 coulombs. If you want, you can just use the letter C. Okay? Who's tried the third one? Try number 3 right now. Alright, it looks like most people are getting this here. Write the letters I, Q, and T. How long will it take? 12 amps. That is my I. To move 1600 coulombs of charge, that's this one here. We're solving for time, right? Mason, what's the formula for time?
My dad
Q over I, exactly. We tend to use the small letter T, by the way. Q is going to be 1600. The I is 12. T is, what's 1600 divided by 12? How much? I think that sounds right. 133.3 seconds. Awesome. Okay. You have some practice ones to do. Okay? I will be posting the answers. Guys, listen. I need 30 seconds. 30 seconds. Okay? I will be posting the answers on the bulletin board. You can go and check. If you have a QR code reader on your phone, you can scan that to see the answers. If you're really having trouble, the QR code at the bottom here, you can scan it and watch me on YouTube do all the answers. There's no excuse for saying, I don't know how to do this.
Cool.
Okay? When you're done that, I urge you to get working on that history project. I'm going to start handing out portfolios right away.
How do you scan stuff? Do you get like an app on your back?
Go.
Hey, watch Chris.
Thank you for waiting, Charlie.